Hello everyone. Hope you are doing very good. So, as you know, first chapter in our 10th class mathematics is real number and it is a very important chapter. So, let's start. First of all, before knowing the real number, you should know that what is the broadest classification of numbers. Okay. So, if I ask you from class 1 only, you have started to learn about numbers. Okay. Your mother, your father, your first teacher, they have told you about numbers. What is number 1, 2, 3, 4, 5, 6. So, suppose I ask you what is the broadest classification of numbers. Okay. So, can you think about the broadest classification of numbers? Okay, some students might know. Okay, let us discuss. First of all, the broadest classification are numbers is as complex numbers. Okay, the broadest classification of numbers is complex. Now, complex numbers are numbers which are of type a plus ib. Okay, where this part is called, this a part is called real part and b part is called imaginary part. Okay, so this complex number is not in your syllabus right now. We will discuss it in higher levels. Okay, so now complex number get divided in two parts, that is real numbers and imaginary numbers. Okay, so you have to study in your syllabus real numbers. Okay, real numbers are the numbers which you can see or observe in your life every day. Okay, as if I ask you, suppose if I do ask you, what is your age? Then you will reply, suppose 1, 2, 3, 4, whatever is your age. Okay, suppose I ask you how many family members are there in your family, okay, or whatever be the question can be of this type. Okay, so real numbers are those numbers which you observe in your life on a daily basis. Now, the classification of real numbers. So, real numbers get divided basically in two parts. Okay, this classification you have studied in class 9th as well. Okay, student who doesn't know, let's discuss this in brief, that real numbers get divided in two parts, rational number and irrational. Okay, now if you do know what are the rational numbers and what are the irrational numbers. Okay, so if I am going to say here that irrational numbers are those numbers which doesn't terminate after decimal and don't follow a particular pattern. Suppose I do have a number of the type 1.2356789141, something like this. So this is not going to be terminated after decimal. Okay, and this number is also not following any pattern. Okay, but in rational number, these are of two types. Okay, one number is we called terminating number. Okay, so terminating number of like 1 by 2, 1 by 5, that is the numbers which get stopped after a fixed point. Okay, like 1.257 0.25, 0.225. These numbers get stopped by a particular distance. Okay. And second number are recurring numbers. Okay. Like numbers you must have seen 1 by 3. This number is of like 0.33333. Okay. Similarly 0.67777. So these numbers do follow a particular pattern after decimal or get terminated. So on this basis real number get divided in two parts, rational number and irrational numbers. Now as we can see, rational number also get divided in two parts. Okay, these are, what are these? One is fraction. Okay, and second is integer. So fraction is what numbers? In which, suppose if number is a by b form, rational numbers are of a by b form. In those, b is not equals to 1 in its simplest form. Suppose 2 by 3, 5 by 7. Okay, so these numbers are fraction numbers, okay, in which if they are written in a by b in their simplest form, then the denominator is not equals to 1. So obviously in integers you can say these are of type a by b in which in its simplest form b is equals to 1. Suppose there is a number 4 by 2. Is it an integer? Obviously, because in its simplest form, this is equals to 2. Okay, so 2, 3, 5, minus 2, minus 3, these numbers. Okay, now from here we can divide our integers. So integers are of two types, or we can say three types: negative, 0, and positive. Okay, so from here we can say that minus 3, minus 2, minus 1, dash, 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 this number. 0, you know, and 1, 2, 3, 4, 5. These are positive integers. Okay, so here we can say that 0 plus positive, these numbers are called whole numbers. Okay, 0 plus positive, these integers are called whole. Okay, only positive integers are called natural numbers. Okay, so here we have seen a broad classification of our numbers. In brief, we have tried to understand that how we can classify our numbers and how we can identify that which number is of which type. So now we are going to relate it that here in class 9th you begin your exploration of world of numbers, okay, of real numbers, and encountered irrational numbers. Okay, so you have already proved, okay, and I tried to identify that how we can identify a irrational number. So here we are going to start our discussion on real numbers. Okay, so first of all, in real numbers, we are going to know about the fundamental theorem of arithmetic. Okay, so let's see. What does fundamental theorem of arithmetic says? So here you can see a statement that every composite number can be expressed as a product of prime and this factorization is unique apart from the order in which the prime factors occur. Okay, so here there are many terminologies being used which some of you may not be aware of. Okay, so let's discuss first those things. Okay, so first of all, if you can see numbers, okay, numbers. So our positive numbers, some natural numbers, are of two types on the basis of factors. We do have prime numbers and we do have composite number. Okay. So for natural numbers, we can divide our numbers on the basis of factors for two types, prime and composite numbers. Okay. So first of all, you must know that what is the factor. Suppose if we do have a number 10, then what are these factors? The number which divides 10, that is 1, 2, 5 and 10. So these are the factors of 10. If somebody doesn't know what is a factor, then you can write down a factor of a number are those numbers which divides that particular number. Okay. So now prime numbers are those numbers which only have two factors. One and that number itself. Okay. So prime numbers are those numbers which have only two factors, one and that number itself. Suppose if you take 2, then it has two factors, 1 and 2. If take 3, 1 and 3. Okay, similarly 5, 7. Okay, these numbers are prime numbers. Now, if you are going to take composite numbers, then numbers which have more than two factors. Okay. So one, that number itself and any other number. Okay. Suppose we do have a number 4. So for 4 we can see that 1 is a factor, 4 is a factor and 2 is also a factor. So for 4 there are 3 factors. So this is a composite number. Okay. So now you have basically known that what are prime numbers and what are composite numbers. Okay. So again, prime numbers are those numbers which do have only two factors, one and that number itself. And composite number are those number which do have more than two factors. Now, I am going to ask you a very interesting question. What do you think about 1? Is 1 a prime number? Is 1 a composite number? Okay. So many of you must be answering 1 is a prime. Okay. So 1 is neither prime nor composite, because what have we seen about prime? That this must have two factors. Okay. So 1 have only one factor. Okay. So you can write down that 1 is neither prime and nor composite, because it doesn't fall in category of any. Okay, so I think here we are very clear about prime and composite number. Okay, so now we are returning back towards our definition of fundamental theorem of arithmetic. What does it say? It says that every composite number can be expressed or factorized in such a way that a product of primes means every composite number can be written in product of primes, and this factorization is unique apart from the order in which the prime factors occur. Okay, so this is a long definition. Many of you must have been confused. No problem. We will discuss. Okay. So let's try to see it with some examples which are being discussed here. Suppose they have taken some long example. First, we will try to discuss it with some short examples. Okay. Let's take a very short number, that is 24. 24. Okay. So, is 24 a prime number or a composite number? Yes. 24, it have factors 1, 2, 3, because 3 as well divides, 4 divides it, 8 divides it. So, this has more than 2 factors obviously. So, this is not the prime number. Okay, so this is a composite. Now, what does our definition say? That every composite number can be written in product of primes if, okay, or in their powers with respect to their orders. Okay, so now for 24, if you are going to find out its factors, okay, so what are its factors? If you can write it as 8 into 3. Okay, so now is 8 a prime? 3 is a prime. Okay, so now try to break down it in the form of primes. Okay, so now we can write it as 4 into 2 into 3. Now here 4 is not a prime. Okay, so now we can write it as 2 into 2 into 2 into 3. So this is equals to 2 cube into 3. Okay, 2 cube into 3. So here we have write a composite number in product of primes as in the definition they have said. We will study it once again. Every composite number can be expressed as a product of primes. Okay, so 24, what we have written? 24, we have written 24 as 2 cube into 3. Okay, so we have written our composite number in product of prime, and this prime factorization is unique, means there cannot be any other prime numbers in which this factorization can be written only if we can change its order. We can write it as 3 into 2 cube as. Okay, so this is what our fundamental theorem of arithmetic says, that every composite number can be expressed as product of prime, and this prime factorization is unique apart from the order in which this prime factorization occurs. Means this can be written as 2 cube into 3 or 3 into 2 cube. No other factorization of this number is possible. Okay, so I think this is very clear. Now, if we are going to see what they have done here, okay, so again you can see that they have written this number 32760 as 2 cube into 3 square into 5 into 7 into 13. So how many prime numbers are here being used? 1, 2, 3, 4, 5. Okay, so this is a, because here every number is what? Every number here is a prime number. Okay, so every number here is a prime number. Okay, so we can say that this number is being written as a product of primes. Okay, so if you are, you can change its order as well. Okay, some may say that we can write 3 square earlier and 2 cube later. So that is not an issue. Okay, because some student might get confused with, so what is the order? Okay, so this is the order. But no composite numbers must occur here in prime. Okay, so this was the our discussion and some things we have discussed. Okay, now example number 1, here we will discuss that consider the numbers 4 to the power n, where n is a natural number. Check whether there is any value of n for which 4 to the power n ends with digit 0. Now this is a very interesting question and we will discuss here some key concepts. They are asking us about 4 to the power n. Okay, so 4 to the power n. Okay, and can, for any value of n, this number may end with 0. Okay, so first of all, we will try to prime factorize it. Okay, so we can write 4 as 2 square and n power is here. Now, if you have studied power very well in earlier classes, and if powers are like this, then powers get multiplied. Okay, so here what we can write, 4 to the power n, we can write it as 2 to the power 2n. Okay, 2 to the power 2n. Now, 4 to the power n has only a prime factor, that is 2. Now, any number that ends with 0, suppose there is a number 140 that ends with 0, then this must be a multiple of 10. Means 10 must be a factor of this number. Okay, if 10 must be a factor of this number, then in its prime factorization, 5 and 2 must occur. 5 and 2 must occur. So, for any number which ends with 0, in that prime factorization, 5 and 2 must occur. Okay. So, here we can clearly see that in 4 to the power n prime factorization, there is no 5 in prime factorization. So, we can clearly say that 4 to the power n can never end with 0. Okay. So, this statement is wrong. Clear? Okay. So, this was our example 1. Now, we have to find LCM and HCF of numbers using prime factorization method. Okay. So, okay, that is a completely new concept. So, that we will discuss in our next class. Okay. Today, I am keeping it here. Okay. Closing it here. Okay. So, do revise it. Ask if there are any doubts. Okay. Otherwise, we will discuss our LCM and HCF concept in new class. Okay. That's all for today. Thank you so much.